Namaste, this is Maulya, studying in Sri Venkateshwara College of Engineering, 5th SEM from the department. In this presentation, we're gonna discuss about the congestion control techniques, TCP congestion control, network traffic management, congestion avoidance versus congestion control, and the future trends of this congestion control. Now let's discuss about this congestion control. This congestion control refers to the technique and mechanism used to regulate the flow of data in a computer network to prevent the congestion which occurs when a network resources are overwhelmed by the volume of data being transmitted. There are the key components of the congestion control, that is monitoring the network conditions, reacting to congestion signals, adjusting transmission rates to alleviate congestion. What are the importance of managing this computer networks is that we get the network reliability, quality of service, user experience and economic impact. These are the important aspects for which the managing network congestion becomes an important task. So moving on to the techniques we use for the congestion control. Congestion control techniques are essential for managing network traffic and ensuring the optimal performance, which is the actual performance. Several algorithms and mechanisms have been developed to address congestion in computer networks. So moving on to the overview of this congestion control algorithms, we come across the additive increase and multiplicative decrease, that is AIMD. AIMD is a classical congestion control algorithm used in many transport protocols using TCP. TCP is nothing but the transmission control protocols. Next, moving on to the slow start. Slow start is another TCP traffic control protocol congestion control mechanism designed to ramp up the transmission rate gradually. Next, moving on to the fast recovery. Fast recovery is an enhancement to the TCP congestion control that helps in the expected process after the packet loss. So here we're gonna discuss about the transmission control protocol, that is congestion control. So TCP, transmission control protocol, it employs sophisticated congestion control mechanism to manage network congestion effectively, ensuring reliable data transmission without overwhelming the networks. Here is an overview of TCP congestion control mechanism and how TCP react to congestion signals. AIMD, we have discussed in the previous slides about AIMD, slow start and fast recovery. Now let's discuss that in the brief. AIMD, additive increase multiplicative decrease. It is a fundamental congestion control algorithm used in transmission control protocols. When the network is operating below the capacity, this TCP increases the congestion window size linearly, that is additively increases. Upon detecting congestion, example packet loss, TCP reduces the congestion window size multiplicatively. Next, moving on to the slow start. Slow start is an algorithm used by transmission control protocols to gradually increase the transmission rate when establishing a new connection or recovering from the congestion. TCP starts with conservative initial congestion window size and exponentially increase it until it reaches a predefined threshold or encounters a congestion. Next, moving on to the fast recovery. Fast recovery is a mechanism in TCP that enhances the recovery process after the packet loss. When this transmission control protocols, it detects the packet loss through the triple duplicate acknowledgement, it enters through the fast recovery, reducing the congestion window size to approximately half and performing selectively retransmission for the recovery of the lost packets. As we come across the traffic in the society due to the overusing of the personal vehicles, The same happens in the computer, that is the network traffic management. The efficient traffic management is essential for effective congestion control in computer networks. Let's explore why traffic management is crucial and the techniques used to manage network traffic efficiently. What are the importance of this traffic management in congestion control? The resource optimization. Traffic management ensures that the network resources are allocated efficiently, maximize their utilization by minimizing congestion and potential bottlenecks. Next, coming to the quality of service, that is QoS assurance. That is effectively traffic management helps maintain consistent quality of service level by prioritizing the critical traffic types such as real-time communication or mission critical data over less sensitive traffic. Next, moving on to the congestion avoidance. By regulating the flow of data, traffic management strategies help prevent congestion before it occurs, improving overall network performance and user experience. It takes the responsibility to avoid the congestion before the congestion happens. Next comes the scalability. Proper traffic management allows network to scale effectively, accommodating increase in the demand without sacrificing the performance or reliability. Congestion avoidance and the congestion control are the two different terms which we're going to discuss in this slide. Congestion avoidance refers to the proactive measures taken to prevent networks congestion from occurring in the first place. Coming to the congestion control refers to the reactive measures taken to alleviate congestion once it has occurred in the network. Congestion avoidance occurs before the occurrence of the congestion. Congestion control occurs after the occurrence of the congestion. Next, coming to the strategies. Congestion avoidance strategies focus on monitoring network condition and adjusting transmission rates or traffic policies before the congestion occurs. Next, coming to the congestion control. Congestion control strategies focus on identifying congestion events and mitigating their impacts on network performance through adaptive adjustments. The goal of this congestion avoidance is to maintain the steady environment performance by preemptively managing traffic to prevent the congestion and associated performance degradation. The primary goal of this congestion control is to provide the network stability and performance to the network after the congestion occurs, so that there will be no compromise in the performance or reliability. Now let's discuss about the future trends of this congestion control. As computer networks continues to evolve and face increasing demands for higher performance and reliability, several emerging technologies and trends are shaping the future of congestion control. Now let's explore some of these key trends, that is machine learning and artificial intelligence. They are being applied to congestion control to develop more adaptive and predictive algorithms. Next, coming to the SDN, that is software defined networking. It decouples network control and data forwarding functions, enabling centralized management and programmability of network resources. Next, moving on to the edge computing and edge networking. Edge computing brings computational resource closer to end users, Internet of Things, reducing the latency and bandwidth consumption by processing data locally. Now let's summarize what we have learned through these slides. Congestion control is the process of regulating the flow of data in a network to prevent congestion, which can lead to degraded performance and reliability. Transmission control protocol congestion control mechanisms such as AIMD, slow start and fast recovery. It plays a crucial role in managing congestion reactively and dynamically adjusting transmission parameters to alleviate congestion. Next comes the traffic management techniques, including that quality of service, traffic shaping and loading balancing are essential for both congestion avoidance as well as the congestion control. The difference we have discussed it, ensuring equitable resource allocation and consistent QoS level, that is quality of service level. Future trends we have discussed, that is machine learning, then software development, networking, edge computing, and quantum networking. So these are the main key points, and the mainly it's a summary of the slides we have discussed in this presentation. Thank you for watching. Please do like the video. Thank you.